All right, welcome to the end of Chapter 4. This is the last section we're going to see in Chapter 4, and it is about quadratic inequalities instead of quadratic equations. So we've solved linear inequalities in the past. Remember, with linear inequalities, we have to think if we're going to have a solid line or a dotted line, and then we have to figure out which side that we are going to shade. It's exactly the same with parabolas. We decide if we're going to graph the parabola as a solid parabola, as a dotted parabola, and if we're going to shade inside or outside of the parabola. And then we're also going to talk about how to solve them, meaning we're going to ask ourselves when are they greater than or equal or less than or equal to 0. So quadratic inequality looks like this. Here I have y is greater than x squared minus 3x plus 2. We have up until now talked about how to graph y equals x squared minus 3x plus 2. So we're going to do some of the same process. And step 1 is to graph our parabola. So there's a couple different ways, of course, that you could do that. You could do x equals negative b over 2a. So x equals negative 3, so positive 3 over 2 times 1. So that would be 3 halves. And then if we were going to plug that in to a table of values, we put 3 halves in the middle. And when we plug in 3 halves, we get negative 1/4. And you can see the work up here. Remember, 3 halves is 1.5, so if I was going to plug in one number bigger and one number less, I would plug in 2 and 1. And when I plug those in, I get 0 when I plug in 1 and 2, and when I plug in 0 and 3, I get 2. So you can see those points over here on the graph. Here's my vertex. Here are my zeros at 1, 0, and 2, 0. And then I have 0, 2, and 3, 2. And we graph that parabola. Since it's greater than and not greater than or equal to, there's no line underneath the greater than, we graph our parabola as a dotted parabola instead of as a solid parabola. After that, we test a point. Here we're testing a point inside the parabola, so if we test the point 1, 2, we put 2 in for y and 1 in for x, and we're asking ourselves, does this point make this true or not? If we simplify, we get 2 is greater than 0, which is true. So since this point makes it true and it's inside the parabola, we're going to shade inside the parabola. So it would look like this. All of the shading would be inside. So this would be the solutions. All of the points in this shaded area, not including the points on the parabola, would make this inequality true. So this is graphing a quadratic inequality, not solving it, but just graphing it. Okay, so you guys try this one. Your answer here is D. And notice it is a dotted parabola. This one opened down. When you tested a point inside, it should have been true, so you should have shaded in there. Okay, now this time we're moving on from just graphing to solving. But we're going to solve by graphing. Okay, so we're going to graph, but we're asking ourselves, where does the parabola have points that are less than 0. Okay, so we have x squared minus 4x plus 3. We're asking where is that less than 0? What x values make this expression less than 0? And that will be the x values where our parabola is below the x-axis, because less than 0 would be below the x-axis, right? So, for example, if I just kind of draw this in general, if this is my parabola, this part of my parabola right here is all of my negative y values. So I'd be asking myself, what are these x values here that correspond to negative y values, right? So our related equation would be x squared minus 4x plus 3 equals 0. We're going to graph that first. And actually here we're going to factor it so that we can find our x-intercepts. So when I factor this, I get x minus 3 times x minus 1. So I set each factor equal to 0, and when I solve those, so here I'm adding 3 to both sides, so I get x equals 3. And here I'm adding 1 to both sides, so I get x equals 1. So if we were looking at this picture up here, this would be the point 1, 0, and this would be the point 3, 0. Now, if we sketch the graph of this parabola, we know it opens up, and I know that these are my two x-intercepts. Okay, so just like the picture we had on the previous page, where are the x values that correspond to this piece of the graph that's below the x-axis, right? only these x values in here. Once I get to an x value that's beyond 3, let's say 4, that x value corresponds to a piece of the parabola that's above the x-axis. So that would be positive, not negative. That'd be greater than 0. If I looked on this side, if I picked 0, well, that corresponds with a part that's above the x-axis. So only these x values between 1 and 3 give me y values that are less than 0. So this is my solution set. X has to be between 1 and 3, but not equal to, because our original problem was just less than, not less than or equal to. All right, you guys try the same thing with this one. Your answer should be A. And the reason that's the case is because when we factor, we get x plus 2 times x plus 3 equals 0. So that means my x-intercepts are -2 and -3. This parabola opens up because A is positive, right? So where are the x values that give me values y values that are less than 0? Well, it's between -3 and -2. Okay, so this time we're going to look at one that is greater than. So this time we're doing greater than or equal to 0. So here I have 0 is less than or equal to -2x squared minus 6x plus 1. Remember, that's the same thing as writing -2x squared minus 6x plus 1 is greater than or equal to 0. So we're going to solve this by graphing. And this time I'm going to be looking for my x values where the graph is on and above the x-axis. On and above the x-axis because I'm looking for greater than or equal to 0. So we're going to start by finding the roots, solutions, x-intercepts. So there's our related equation. Here they're going to have you use the quadratic formula. You can do anything that would work. Remember, quadratic formula and completing the square always work. Factoring sometimes works. So here we plug in our correct quadratic formula values. B is -6, A is -2, and C is 1. And when we simplify, we get these two results. And in this case, since we're going to try to graph, we're going to estimate them in our calculator. Here we're rounding to the nearest hundredth because 44 is not a perfect square, so we're going to have irrational roots instead of rational ones. So when we sketch our graph, we know that A is negative here, so I know it's going to open downward. Here is the x-intercept that's -3.16, and here is about 0.16. And I sketch my parabola, it opens downward. I could get my exact vertex if I wanted to graph precisely. And I'm asking myself, okay, what x values give me this part of my graph that's greater than 0, that's above the x-axis? Well, in this case, it's the x values between my two x-intercepts. If I plug in any x value here between my x-intercepts, its corresponding y value is going to be greater than or equal to 0. And that's what we're asking for. So our solution set would be x has to be between these two things. We could also write it as 6 minus the square root of 44, if we wanted to be exact, is less than or equal to x, which is less than or equal to 6 plus the square root of 44 over -4. And if we test one, we can see if it actually works. So if we test x equals -4, which is below, less than -3.16, if we plug that in, we see that it is false, right? So if we go back to our graph, if I plug in this number down here, it makes my inequality false. So I know it can't be the x values out here. It has to be the x values in between my x-intercepts. If I test 0, I get something that's true. And if I test 1, I get something that's not true. And so that's another way to test whether or not the area that you shaded is correct. Plug in some of the x values in that shaded area and outside of it, and figure out if they're true or false, and that'll tell you if you wrote down the right inequality. So you guys try this one. All right, here you should have gotten C. Here would be the corresponding graph. Here I showed you the work with quadratic formula if you were wanting to check how you did on that. These are my two x-intercepts, so I have it looks like almost -3, but not quite, and just a little bit over +1. And in this case, since I'm looking for where it's greater than or equal to 0, I have to shade to the right. because here are my parts above the x-axis, out here and out here. So this one actually looks like an OR inequality when I write it. X has to be greater than or equal to 1.27 or less than or equal to negative 2.77. These values here in the middle between the x-intercepts give me y values that are negative, and I'm looking for y values that are positive. Alright, let's do example 5 first, actually. So that way we can make sure to show you how to solve algebraically. When we're solving algebraically, first we want to solve the quadratic equation. So again, we're going to want to find the x-intercepts, or the roots, or the zeros, right? That's always what I want to do first. I'm going to use those roots or zeros to figure out where my x values are that would make this true. So we're going to set it equal to 0, like we do anytime we solve a quadratic equation. And this one actually factors pretty easily. So two numbers that multiply to negative 2 and add up to positive 1 are positive 2 and negative 1. And since my a value is 1, I can put those directly into my binomial. So I have x plus 2 times x minus 1 equals 0. I set each factor equal to 0 by the zero product property, and I get x equals negative 2, because here I subtract 2 from both sides. And here I add 1, and so I get x equals 1. Those are my two x-intercepts. So what I'm going to do is I'm going to think about what those two x-intercepts, negative 2 and positive 1, would look like on a number line. So I'm going to plot those points just like that. And then I'm going to plug in some points and find out which of these intervals would give me something positive and which would give me something negative. Remember, we're looking for things that are going to be less than or equal to 0, because if I got this subtracted 2 from both sides, oops, sorry about that, I'd have x squared plus x minus 2 is less than or equal to 0. So I'm looking for what x values, when I plug them in, give me something less than or equal to 0. So we're going to test one point in each interval. So here, notice they're testing a point that's less than negative 2. So they chose to test negative 3. When they plug negative 3 in to their original inequality, it does not work. I get 6 is less than or equal to 2, which is false, right? If I test a number between negative 2 and 1, so something in this interval, I get something that is true, so it works here. And when I test something where x is greater than 1, I get something that is false. So where are my solutions? Well, they have to be where it's true. So between negative 2 and 1. It doesn't work here, and it doesn't work here. So I would write the set of x such that negative 2 is less than or equal to x, which is less than or equal to 1. Why am I saying less than or equal to? Because that is we have the equal to in our original inequality, so it's going to be less than or equal to. So this would be the set of x values that would make that original inequality true. So I want you guys to try the same thing here. Alright, your answer here should have been A, negative 3 is less than or equal to x, which is less than or equal to negative 2. Here's the work for the factoring if you need to see how we got our x-intercepts of negative 3 and negative 2. And then basically if we plug in a point that's less than negative 3, say negative 4, that's going to make this inequality false. If I plug in something between negative 3 and negative 2, like negative 2.5, it's going to make this true. And if I plug in something greater than negative 2, like 0, you can see that pretty easily. We get 0 is less than or equal to negative 6, which is false. So I get a false area up here. So my solutions are between negative 3 and negative 2. Okay, let's go back to example 4 real quick just to at least talk about the setup. So here they give us an equation that tells us the height of a ball above the ground after it's thrown upward at 40 feet per second. So this is the function that models it. They're asking me where is the height in feet. I'm sorry, the height is given in feet and the time is in seconds. At what time, so we want to find our x, is the ball within 15 feet of the ground. So that means it's 15 feet above the ground or less. So what we're going to do is we're going to say, okay, when is this function less than or equal to 15? When is the height less than or equal to 15? So we set it up like this, and we get a quadratic inequality just like we had before. And if we do use a graphing calculator for this, we find our two zeros, 0.46 and 2.04. And we're looking for the x values that make it less than 0.